I first walked past the disused rail depot on Vozdvizhenka Street, Moscow, assuming it to be another remnant of late imperial industrial expansion. The official record states its construction began in 1887 under the direction of engineer Alexei Alabian, a figure who appears in only a handful of regional planning documents. An archival photograph from 1891, housed in the Municipal Transport Archive, shows workers posing before the unfinished eastern wall. Behind them, partly concealed, is a stone archway cut with a symmetry far too exact for hand-tooled equipment of the time. During a renovation survey from 1964, a notation mentions a subsurface hydraulic cavity of unknown purpose, sealed prior to inspection. No explanation follows. I had come expecting soot, blackened brick, and predictable Victorian geometry, but the deeper I looked, the more the proportions defied the era. The dome-like curvature beneath the floorboards resembled what some researchers classify as Tartarian sub-pressure architecture. Something here is wrong, and quietly asking to be followed. The depot at Vozdvizhenka Street sits awkwardly between later Soviet structures, its red brick softened by a century of weather, but still unmistakably late imperial. I entered assuming my work would be little more than verifying measurements against municipal records. The official story, written succinctly in the 1887 City Transport Registry, describes the depot as one of several expansions designed to modernize distribution of freight entering the city from the southwest. It was the kind of phrasing that repeated across cities of the era: generic progress, generic expansion. The registry attributes the design to engineer Alexei P. Alabian, about whom little information survives. His project ledger, stored in the same archive, contains only sparse entries: deliveries of brick shipments, acquisition of timber, scheduling of workers. No architectural sketches appear in his book, which is unusual for a lead engineer responsible for a structure of this complexity. Instead, the technical drawings come from another hand entirely, signed only with initials NV. The earliest surviving photograph, dated June 1891, shows workers standing ankle-deep in mud before the eastern wall. The quality is grainy but still legible. Just behind them, half hidden in shadow, is a stone archway that appears far too refined for a depot supposedly built from modest materials and local labor. And the stones are cut with a precision I would expect from 20th century machines, not from the hand tools available to workers in 18 Moscow. I enlarged a digital scan of the photograph, tracing the curvature. It forms a near-perfect 2:1 ratio, identical to the geometric proportions found in fortified star-shaped complexes across regions that early European atlases labeled Great Tartary. These proportions weren't known to be used in Russian industrial architecture. Yet here they were, behind a group of workers who, judging by their posture, seemed unaware of the significance of what stood behind them. When I cross-referenced the photograph with the official blueprint for the depot, the archway did not exist. The location where it appears in the photograph is marked simply as supporting wall, unbroken. It is strange to find a feature in a photograph that the blueprint denies. I walked the length of the eastern wall, the one visible in the image. The brickwork shows 3 distinct layers of replacement, most likely from Soviet-era maintenance. But beneath the many patches near the floor, I found faint seams in the mortar, indicating a former opening. The archway had indeed been sealed exactly where the photograph placed it. Why seal a structural feature before the building was even completed? The ledger provides no answer. None of the renovation logs mention the sealed archway either. It seems to disappear from the record entirely. I paused, noting the sensation I often try to ignore, the quiet pressure of contradiction building beneath every official explanation. The arch belonged somewhere else, to something older or more precise than the 1880s industrial project described by the registry. I ended that day's investigation by asking myself a small question I couldn't yet articulate aloud. Why does a supposedly ordinary depot begin with a feature that aligns more closely with Tartarian architectural ratios than with Russian industrial norms? 2 weeks after my initial visit, I returned to inspect the depot's sub-basement, assuming at the time that it had been added during a 1904 modernization, as cited in the city's renovation records. But the dates quickly dissolved under scrutiny. The 1964 inspection report, typed with the clipped precision of Soviet bureaucratic style, mentions a subsurface hydraulic cavity of unknown purpose sealed prior to inspection. No such cavity appears on the 1904 drawings, and certainly not in the 1887 plans. What caught my attention more sharply, however, was a single line in the 1964 memo: foundation layer exposed, lower vault predates, upper layer predates. A word that should not appear in a renovation log for a depot supposedly constructed on bare ground in 1887. The sub-basement is cramped, illuminated only by the narrow beam of my flashlight. The brickwork shifts colour abruptly halfway down the walls, the upper portion a familiar imperial red, the lower a deeper baked hue more typical of 18th century brick-making. The mortar seams differ as well. The lower vault is laid with a consistency suggesting a more precise, possibly mechanized technique, while the upper is uneven, rushed. I pressed my fingers into the jointing between bricks of the lower layer. The seams were thin, tighter than what handwork of the 1800s typically achieved. The curvature of the vault extended deeper than the blueprint suggests, forming a pronounced dome shape that is entirely absent from industrial architecture but common in the subterranean structures identified by some researchers as Tartarian sub-pressure chambers, vaults intended allegedly to regulate environmental pressure, though this remains speculative. A rolled map stored in the archive, printed in Germany in 1801, caught my attention as well. Though not detailed at the scale of individual city districts, it labels a wide swath of Eurasia, including parts of what is now central Russia, as Tartary. The map's boundaries blur where Moscow now sprawls. Early cartographers were inconsistent with their naming conventions, yet the presence of the label near this district subtly echoes the unusualness of the vault I was now crouched inside. What is the relationship between an 1801 map and an 1887 depot? Nothing officially, but spatial coincidence has its own gravity. I studied the so-called hydraulic cavity. It was sealed with a poured concrete cap, clearly a Soviet addition. Along the rim, faint tool marks indicated metal fittings had once protruded from the cavity. The 1964 report did not elaborate on these fittings, nor did it speculate on their purpose. I inserted a thin borescope camera through a gap where the concrete seal cracked slightly at the edge. The interior revealed something that chilled me more than I expected: a circular depression and radial grooves, forming a pattern nearly identical to the foundational markings found beneath the Tobolsk Star Fort ruins. Structures some alternative researchers insist were part of an advanced Tartarian hydraulic network. Of course, mainstream historians deny any connection. They attribute such grooves to drainage channels or early industrial infrastructure, yet no known Russian depot used such systems, and certainly not before 1900. As I withdrew the camera, I felt the weight of the sealed space pressing upward, as if something beneath had been intentionally muted. The silence of the lower vault seemed deeper, older, and out of place. The official records offered no contradiction because they offered nothing at all, and I was left with the uncomfortable realization that the depot's foundation was built atop another architecture, one neither documented nor explained. The question formed again, sharper now. If the lower vault predates the depot, why was it sealed before construction was completed? It was not until my third major site visit that I began acknowledging the emerging pattern, though I resisted naming it. The north wing of the depot includes a sequence of maintenance rooms once used for equipment storage. In 1928, a renovation team removed several iron components from these rooms, documenting their removal with unusual brevity. Machinery obsolete, purpose unclear. The accompanying photograph, a faded silver gelatin print, shows 3 workers standing beside what appears to be a bundle of iron brackets. At first glance, they look like decorative supports, curved, elegant, symmetrical, but their thickness and uniformity suggest a structural purpose. I measured a surviving bracket still mounted to the wall. Its curvature traced a perfect arc, machined with a precision that would challenge many workshops of the 1880s. Ironwork of the period typically bears unique tool signatures, hammer strikes, uneven bends, but these brackets showed none. Their surfaces were smooth, nearly polished despite decades of dust. This specific form, curved, rib-like, evenly spaced, appears in photographs of abandoned roundhouses in Kazakhstan, a region once labelled independent Tartary, in mid-18th century maps. I cross-referenced images from the Oskerman Roundhouse, built officially in 1903. Its internal iron ribs matched those in the depot almost exactly, down to the radius of curvature and the spacing between mounting points. Identical geometry across thousands of kilometers would be unusual even today. In the 19th century, it borders on impossible unless copied from a shared template or inherited from earlier structures. The 1928 renovation notes ordered all redundant conduits removed. When I traced the remaining stubs protruding from the depot wall, I found their alignments too deliberate, forming a radial pattern that centered on the location of the sealed hydraulic cavity in the sub-basement. This radial alignment mirrors what alternative researchers working from fragments of records and surviving architecture refer to as a Tartarian distribution pattern, where conduits feed into or draw from a central pressure chamber. I paused my work to stare at the wall. The geometry felt intentional, not decorative or haphazard. The official documents, however, insist these were decorative metal supports, unrelated to structural or hydraulic functions. Decorative metal supports do not require pressure-rated joints. The first pattern had emerged, precision, too advanced for the cited era, structural features denied by the blueprint, conduits aligned to a concealed central chamber, identical geometry appearing in distant locations historically labelled as Tartary. My conclusion remained restrained, but unmistakable. Something older lay beneath the industrial era surface, something the builders repurposed or sealed rather than constructed. The depot's north wing, once mundane, now whispered the first coherent hint of a larger network, one quietly erased in records but stubbornly present in architecture. My investigation expanded beyond the confines of Moscow when a researcher in Ryazan sent me a photograph from 1882 that he claimed I needed to see. The image, preserved in the Ryazan Oblast archive, shows workers standing beside an unfinished rail spur, its wooden ties laid neatly, the rails freshly installed. But the line ends abruptly at the base of a hill. Not in the present day, after abandonment or erosion, but in the original construction photograph itself. The official engineering survey of 1874, drawn by cartographer Ivan Mikhailovich Sorin, describes this spur as a connector between two growing industrial centers. Its blueprint shows a continuous line into the valley, yet the photograph contradicts this entirely. The line terminates in open terrain, with no evidence of incomplete grading or planned extension. It simply stops. I travelled to the site, a few kilometres outside modern Ryazan. The hillside remains much as it appears in the image, though softened by vegetation. At the point where the rails once ended, I found a shallow depression. When cleared of leaves, it revealed a recognizable shape, a stone-lined arch, half buried, cut into the base of the hill. Exactly the same curvature as the sealed archway at Vozdvijenka Street. I measured the stone blocks. Their surfaces were smoother than typical 19th century Russian quarrywork, and their dimensional tolerance, deviations under 3 millimeters, was consistent with precision-cut stone found in Tobolsk, Omsk, and other sites which fringe researchers have attributed to Tartarian engineering. The blocks here showed that same characteristic faint striation sometimes seen in photographs of structures alternative researchers classify as Tartarian, parallel grooves too uniform to result from hand tools. Curiously, the 1880 survey map of the area includes a marginal note, pre-existing embankment, foundation unknown. Zorin's handwriting appears next to it with a simple question mark. Why would a rail surveyor in 1880 remark on a pre-existing embankment in an area supposedly undeveloped? And why end the spur line at a hill unless something already existed beneath it? I crawled into the arch, no more than a meter high. Inside I found a narrow corridor carved with unnatural smoothness for its era. The air was heavy, dust undisturbed for decades. Beneath my flashlight beam, the corridor's curvature repeated that exact 2.1 parabola found in structures linked to Tartarian hypotheses, geometries too consistent and widespread to be coincidence. Official interpretations suggest drainage or early industrial tunneling, but such claims disregard the symmetry and finish of the stonework. This corridor was not dug, it was sculpted. I retreated from the hill with the uneasy realization that the Ryazan spur had been built to reach something already there. But before reaching it, construction halted. No explanation survives except the silence of the photograph, rails ending where older architecture began. Again, the same question returned. Why does infrastructure from the 1800s repeatedly intersect older structures treated as if they should not exist? My next lead took me to St. Petersburg's State Rail Archive, a cavernous repository of blueprints, project ledgers, and engineering journals. There I requested all documents related to early rail construction between 1850 and 1870. Of the many folders presented to me, one stood out, a blueprint dated 1861 marked Preliminary Station Design, Northern Corridor. According to the archivist, this blueprint was never associated with any completed building. But when I unrolled it, the paper revealed a level of architectural sophistication entirely out of place for its alleged date. The station design included triple vaults, intricately drafted, with curves rendered so precisely that I questioned whether 1860s drafting tools could produce such uniformity. Older blueprints typically reveal wobbles, uneven ink flow, visible compass pinpoints. None of that appeared here. Every line was crisp, confident. What disturbed me most was that the vaults formed a concealed substructure shaped like an inverted dome. Above ground, the structure was simple, a rectangular hall, modest, almost utilitarian. But beneath it, the blueprint depicted a series of converging arches that formed a nearly perfect dome-like chamber. No above-ground dome was planned. The curvature was entirely subterranean. In Tartarian research circles, such hidden domes are a recurring motif, interpreted as pressure containment, acoustic resonance structures, or part of a supposed energy distribution network. Mainstream historians ignore these claims, attributing such interpretations to speculative misreadings. Yet the blueprint's precision was impossible to ignore. I examined the paper under a magnifying glass. The ink revealed 2 layers, likely the work of 2 individuals decades apart. The newer layer added annotations such as remove lower curvature and simplify foundation. Someone had intentionally erased the dome-like substructure long after the original draft. Why would a 19th century station blueprint contain a subterranean dome never intended to be built? Or, more troubling, was the dome already there and the station was designed to use or cover it? I checked for references to the original drafter. The signature block contained only initials, NV. I cross-checked with the Vozdvizhenka Depot's anonymous drawing sigil. The initials were identical. Could the same drafter have produced both sets of drawings, one for a Moscow depot, the other for an unrealized St. Petersburg station, using techniques far more advanced than the era typically allowed? Finally, the archivist brought me a map attached to the blueprint, printed in 1834, which labeled the surrounding region as Chinese Tartary. Though cartographic conventions varied widely at the time, the presence of the label over northern territories adds an uncanny resonance. This blueprint, with its hidden dome, its impossible precision, sits geographically and conceptually on land, once labeled under the Tartarian umbrella. I left the archive unsettled. The blueprint should not exist in its precise form. Yet it does, and it echoes what I saw in the Moscow depot and the Ryazan corridor. The pattern was no longer isolated, it was replicating. The most startling evidence of all came from Yekaterinburg, where a railway excavation in 1977 exposed something that, even by Soviet standards of concealment, should have been discussed more openly. I obtained a copy of the excavation memo through a contact, an unassuming sheet stamped "Internal Use Only." It described the accidental exposure of a lower railway line beneath the main 1892 Yekaterinburg freight line. According to the memo, lower line predates upper by unknown interval, construction not consistent with known imperial railway methods. That alone would warrant investigation. But the photographs included with the memo pushed the anomaly further. The lower track used granite sleepers, solid blocks of granite carved with exact recesses for iron fittings. Russian rail construction in the 19th century never used granite sleepers. They were too heavy, too labor-intensive, and too precise. Granite sleepers appear only in megalithic or pre-industrial contexts attributed, controversially, by some researchers to remnants of Tartarian engineering. I visited the site. Some of the granite sleepers still protruded from the soil where excavations ceased. Their surfaces bore faint parallel tool marks, machine regular, not hand-chiseled. Each sleeper measured the same length and width as those I had seen in photographs from abandoned lines in Central Asia. Lines, alternative historians argue, belonged to a pre-imperial rail-like network or structural foundation. The gauge of the lower track was broader than modern Russian gauge by exactly 12.5 centimeters. This measurement matches the gauge recorded in 19th century explorers' diaries describing tracks in territories then labeled Tartary on Western maps. These diaries, dismissed by academic historians as misunderstandings of irrigation channels or caravan paths, now seem to echo the evidence lying beneath my feet. A photograph from the 1977 memo revealed something even more unsettling. The lower track's alignment matches the modern freight line perfectly, as if the upper track was laid directly above the older one, copying its orientation. Why would imperial builders construct a new line atop a pre-existing one without acknowledging it? More importantly, who built a granite-based rail-like structure before 1892? The memo ends abruptly. Excavation to cease. Lower line to remain buried. No further inquiry. No explanation, no justification. Burying a more advanced line under a cheaper, newer one suggests a deliberate decision, not an accident of history, but a choice to cover something older and incompatible with the accepted narrative. As I left the site, a dull unease settled over me. The granite sleepers, the broader gauge, the precise alignment, all echoed the vaults, domes, arches, and conduits I had documented elsewhere. Each instance might be dismissed as a quirk or regional anomaly, but together they formed something else, a pattern of inherited infrastructure, erased, sealed, simplified, or denied, where modern rail lines follow the shadow of older ones. And those older structures carry architectural signatures found across lands once mapped as Tartary. By the time I reached Kazan Central Station, I had trained myself to expect inconsistencies. What I found there, however, exceeded anything I had encountered in Moscow, Ryazan, or Yekaterinburg. Kazan Station officially opened in 1896, built in the eclectic imperial style common to the era. Ornate brickwork, decorative arches, wooden beams perched beneath steep gables. Tourists admire the building's surface. Few think about what lies beneath it. The sub-level, first documented in 1897, was sealed in 1933 under an NKVD directive. The archive containing the directive is sparse, but one sentence in the order lingers with unsettling clarity. Remove all lower mechanisms. Document discontinued. Mechanisms beneath a passenger station? I entered the sub-level through a maintenance hatch now used for electrical cabling. The air was stale but cooler than the upper corridors, as if insulated by mass. The walls, illuminated by my flashlight, revealed oversized red bricks, much larger than standard imperial bricks, closer to those seen in structures that some fringe researchers refer to as impossible red brick complexes. These bricks were baked to a hardness beyond that of their upper-level counterparts. Their seams were tight, edges sharp. A craftsman of the 1890s might have produced something similar, but not with this degree of uniformity. Machine consistency of this type does not appear in Russia until decades later. Then I saw the bronze valve. It sat half embedded in the wall, tarnished and dented but unmistakably manufactured. A circular plate about 30 centimeters across, with 4 branching conduits, now severed, once connected to it. The valve's geometry matched the same radial pattern I had seen in the sealed hydraulic cavity beneath the Vozdvizhenka depot. A small engraving circled its outer rim, a geometric pattern of interlocking arcs. The same motif appears in the substructures beneath the Tashkent Star Fort ruins, another site that alternative historians argue belongs to a Tartarian technological system. I documented the valve with care. Then I noticed the floor. A shallow depression formed a perfect arc along the room's edge, concealed under dust. Its curvature mirrored the hidden dome in the St. Petersburg blueprint. I cleared more debris and found that the depression extended into a larger circular chamber, now filled with rubble. This chamber likely housed the lower mechanisms removed in 1933. In my notebook, I copied a quote from a maintenance log dated 1902, written in an elegant but hurried script. Pressure reading anomalous today. Mechanism unresponsive. Report to superior. Pressure reading. Passenger stations do not typically monitor subsurface pressure. The presence of the valve, the curvature of the chamber, the oversized bricks, all indicated a system intended to regulate or distribute something from below. Why beneath a major transportation hub? Some researchers argue that Tartarian infrastructure functioned as a network of sub-pressure chambers interconnected beneath cities now lying on former Tartary map regions. Mainstream scholars dismiss this as fantasy, yet the evidence here was tangible. It required no speculation. The NKVD directive made one thing clear. The sub-level was not simply abandoned, it was deliberately stripped. When I climbed out of the hatch and stood on the station platform, crowded with travelers, luggage, and the mundane hum of daily life, I felt the weight of the silent space beneath their feet. The question grew darker. What system once operated under Kazan, and why was it dismantled so thoroughly in 1933? The deeper I waded into archival material, the more I encountered blank spaces where people should have been. Records that should link, careers that should have left footprints. Nowhere was this more pronounced than in the case of engineer Pavel Krestov. His name first surfaced in a stack of correspondence stored in the Tomsk Regional Archive, dated between 1888 and 1889. The letters were attributed to him, though no personnel file, employment record, or payroll entry exists for any engineer by that name during those years. The letters bear handwriting that shifts subtly from one document to the next, curvature of letters, pressure of the pen, spacing between lines. A handwriting analyst would call it inconsistently consistent, suggesting more than one person was writing as Krestov. The earliest letter describes surveying work along a proposed extension toward Krasnoyarsk. It contains an unusual line. Substructures inherited, not constructed, document all intact segments. Inherited? By whom? The wording implies that Krestov, whoever wrote the letter, was not designing new infrastructure but cataloguing existing structures the railway expansion encountered. This interpretation aligns with a sketch attached to one of the letters, a star-shaped station layout drawn with elegant geometry inconsistent with imperial design conventions of the time. The sketch resembles the outline of star forts found throughout Siberia, ruins that some researchers argue bear Tartarian signatures in their orientation and construction methodology. But rail stations built by the Empire rarely adopted such shapes. Efficiency, not elaborate geometry, guided their layout. Why then would an engineer sketch a star-shaped configuration decades after star forts had fallen out of military use? Another document included a map labelled Chinese Tartary. The map, printed in the 1850s, appears to have been repurposed. Krestov's notes reference certain subterranean vaults aligning to the old boundaries marked on it. From a historian's viewpoint, this is coincidence. Old maps often used outdated labels, but combined with the letters documenting inherited substructures, the coincidences multiplied beyond comfort. Then came the strangest detail. One letter ends with a sentence that feels almost confessional. The foundations appear older than the soil around them. A poetic exaggeration? Maybe. An indication of geological misreading? Possibly. But when cross-referenced with excavation reports from Tomsk indicating a lower brick layer inconsistent with local materials, the line feels less metaphorical. Why would multiple engineers using multiple hands write under a single name describing substructures that do not appear in official records? The Tomsk Archives curator offered one interpretation. Sometimes engineers acted collectively under a single administrative identity, especially in remote regions. But this explanation fails to account for the specificity, the star-shaped designs, the references to inherited vaults, the boundary alignments to Tartary map regions. If Pavel Krestov did not exist, then who authored these letters? And why describe Siberia's railway network as if it were being built atop something much older? The absence of a man can be more revealing than his presence. The Omsk Roundhouse, built officially in 1902, looks unremarkable from the outside. A circular shell of brick, windows spaced at rhythmic intervals, a roof reinforced during Soviet modernization. Workers used it for decades to service locomotives, but its renovation in 1958 reveals yet another crack in the accepted narrative. I obtained the renovation plans from the Omsk State Construction Archive. The cover page reads simply, "Removal of all sub-level structures and associated conduits. Replace with standard concrete footing." Why remove a foundational substructure? The blueprints from 1958 show a complete sub-level beneath the roundhouse, an array of chambers and ribs arranged in geometric harmony. One drawing, labelled Section C, shows iron vault ribs forming a dome-like lower shell. The ribs are evenly spaced and forged from an iron alloy that metallurgists date closer to early 20th century industrial processes than to 1902 hand-forging techniques. In other words, the sub-level's ribs appear newer, more advanced than the upper structure supposedly built later. But that's not the only impossible detail. When I compared the Omsk sub-level diagram to an old blueprint from Tobolsk dated 1890, I discovered that the layout was identical, not similar, identical, down to rib spacing, chamber dimensions, conduit angles, even the notations matched. No two roundhouses in Russia, spread across 1,000 kilometers, should share a sub-level blueprint crafted with this level of precision. I visited the roundhouse's grounds, where traces of the removed sub-level persist. Beneath a patch of cracked asphalt lies a shallow depression, circular, matching the dome curvature drawn in both blueprints. The soil is compacted differently here, suggesting excavation and refill. The 1958 renovation notes contain another haunting line: conduits removed, origin uncertain. Origin uncertain? These conduits were part of the original building, according to official history. Their origin should not be uncertain. One photograph appended to the renovation file shows workers cutting through a conduit made of a strange metallic alloy, smooth, matte, seamless. The image quality is poor, but the conduit's outer layer appears fused rather than welded. This aligns with similar conduits found beneath the Moscow depot, conduits treated as decorative supports in the 1928 renovation, despite their clear alignment with hydraulic functions. Why would the Omsk roundhouse share sub-level geometry with Tobolsk? Why would both share signatures found in Kazan, Yekaterinburg, and Moscow? Why remove these systems in 1958 with no technical explanation? At this point in my investigation, the evidence no longer felt isolated. It formed a lattice, spanning thousands of kilometers, built on patterns modern engineers would struggle to replicate without shared standards. These hidden geometries, valves, domes, ribs, conduits, and chambers, shared something that official Russian railway history does not: a coherence, a consistency, a unifying architectural language, one that mirrors what alternative researchers call Tartarian infrastructure: subterranean, pressure-based, geometrically precise. Standing in the ruins of the Omsk substructure, I realized that renovation in these cases did not simply modernize the building. It erased something, silently, thoroughly, systematically, and the question that had followed me since Moscow now felt heavier. If all these systems were truly built by imperial engineers, why do the records show such meticulous removal and so little construction detail? Who built the originals? I returned to Moscow for what I expected to be a brief period of consolidation, sorting notes, transcribing archival excerpts, organizing photographs. Instead, I found myself drawn deep into the cartographic archives of the Russian State Library, where the maps tell a different story than the histories built upon them. Among the shelves lay atlases dating as far back as the 1760s, printed in France, Germany, the Netherlands, and Britain. Their colors have faded, but one detail recurs across all of them: the label Grand Tartary. Even after the term began to disappear from Western cartography, its ghost lingers in marginalia, in poorly erased captions, in boundaries that look suspiciously like later infrastructure corridors. One such corridor appears on an 1834 survey sketch, a crude map of central Russia drawn decades before the advent of rail. The sketch shows a faint straight line crossing a stretch of land that would become in the 1880s a major freight route. At first I assumed coincidence. Straight lines often appear as early border markers or trade paths. But when I overlaid the sketch on a modern satellite image, the alignment was perfect, not approximate, perfect. When cartographers of the 19th century drew over long distances, Their errors were typically measured in kilometers. Yet this line mirrors the Yekaterinburg freight line with frustrating exactness. I investigated further and discovered similar pre-rail lines on maps of Omsk, Kazan, and Tomsk. These lines matched not only modern railways but also the positions of the substructures I had been studying: the sealed domes, conduits, hydraulic chambers. A correlation formed, a hidden geometry stretching across thousands of kilometers. I turned next to a French atlas printed in 1769 which labels much of Siberia and Central Asia as Grand Tartary. Its engraving shows faint radial spokes extending from major settlements, unexplained, ignored by historians, dismissed as artistic flourishes. Yet the radial spokes match the angles of the hidden domes beneath Kazan, the conduits beneath Vozdvijenka, the rib alignments under Omsk. In the silence of the map room, these resonances accumulated like pressure beneath a curved vault. I noted an entry from the 1769 Atlas's commentary, translated, "Certain regions present geometries which neither the traveller nor the scholar can account for." A relic of confusion, a fleeting observation? Perhaps. But such geometry, replicated across centuries, across vast distances, demands explanation. Mainstream historians argue that maps reflect misunderstanding, not precision. And yet modern rails mirror lines drawn before rails existed. Sub-level vaults match curvature diagrams from drafts no engineer admits to authoring. Corridors beneath hills in Ryazan echo structures drawn by anonymous hands in St. Petersburg. Standing amid these maps, silent witnesses of forgotten cartographers, I felt the first flicker of a realization I had resisted for months. The modern Russian rail system may not have been planned from nothing. It may have been built along the skeleton of something older, something erased before it could be named. My next task was synthesis, comparing architectural substructures across all sites I had visited. This required revisiting 6 stations: Moscow, Kazan, Tobolsk, Tomsk, Omsk, and Samara. Each had undergone renovations at different times with varying degrees of archival documentation, yet all shared one unexpected commonality. Beneath their flat-roofed exteriors lay hidden dome-like vaults, some intact, others fragmented, all curving with suspicious consistency. These domes are invisible from the surface. Their curvature is concealed below multiple floors of brick, timber, and industrial-era reinforcement. Their existence is rarely, if ever, referenced in construction records. I began by sorting photographs from each site and overlaying the curvature diagrams. The radii from different cities matched within a tolerance of less than a centimetre. I repeated the measurements 3 times, doubting the accuracy, but the consistency held. Kazan's chamber matches the hidden vault beneath the Moscow depot. Tobolsk's sealed dome matches the lower rib cage removed from Omsk in 1958. Even Tomsk, where records are scant and the sub-level only partially accessible, shows a curvature that falls neatly into the same geometric ratio. Architectural historians might call this coincidence. Engineers might speak of common techniques. But these sites were constructed decades apart by different architects under different budgets, in regions separated by enormous distances. No common school of engineering existed among them. More troubling still, the hidden domes mirror the sub-pressure curvature described in alternative interpretations of Tartarian architecture, structures designed to distribute load downward and outward, forming pressure-regulated chambers. I compared this curvature to known domes from recognized architectural traditions: Byzantine, Russian Revival, Islamic, Baroque. None match this hidden geometry. The Tartarian hypothesis, long dismissed, fit more closely. A dome inverted, built underground, forming the hidden foundation for an above-ground structure that makes no visible reference to it. In the Samara station, the substructure was partially excavated in 1967. Workers discovered a dome-shaped cavity filled with rubble but lined with stone blocks carved in the same style as the Ryazan corridor arch. Their report, brief and unceremoniously filed, ends with "No infrastructural purpose identified. Fill cavity." Why fill rather than investigate? The deeper I traced these domes, the more they resembled nodes, interconnected chambers spaced with mathematical regularity, each aligned along the same continental axes documented on old Tartary maps. One cannot claim that these domes prove the existence of a lost civilization, but they undeniably reveal a pattern incompatible with the idea that these stations were built independently by imperial engineers. The domes existed first, the stations came later. I whispered this to myself one night, alone in my study, surrounded by blueprints and photographs. These were not built for railways. They were built for something older. The room remained silent, but the evidence spoke loudly. The final threads of my investigation led me to a remote workshop outside Novosibirsk, known colloquially among locals as the Forgotten Shed. Officially, it was designated as a rail maintenance facility built in 1898. In reality, almost nothing in or beneath it corresponds to that date. The workshop itself is unremarkable: wooden beams, corrugated metal roof, cracked windows. What lies beneath it, however, is not. A forgotten 1971 removal order, yellowed, brittle, stamped with the Soviet insignia, describes the extraction of non-standard apparatus deemed incompatible with modern operations. Attached is a photograph of the apparatus before removal. The image shows a large cast-iron vessel with flanged joints on either side, resembling a horizontally oriented pressure cylinder. But its alloy composition, according to a metallurgical analysis appended to the order, includes trace elements not commonly used in Russian cast iron until after 1920, 22 years after the workshop's alleged construction date. This is not a minor discrepancy. This is a technological impossibility. The vessel rested upon two granite plinths, each carved with recesses that fit the vessel's curvature perfectly. Granite plinths do not appear in industrial rail infrastructure, especially not in Siberia. They resemble foundation elements from older architectural traditions associated contentiously with Tartarian construction. The photograph shows pipes running from the vessel into conduits beneath the workshop floor. When I visited the site, these conduits had been filled with debris, but their openings remain visible. Smooth-walled, uniformly circular, with no signs of hand tool construction. The removal order reads, "Scrap unknown apparatus, non-standard fittings, incompatible with steam system." If the apparatus was incompatible with steam systems, then what system was it originally built for? I traced the workshop's foundations and discovered something more unusual. The plinths align with the same cardinal geometry as the sealed domes beneath Kazan and Moscow. This alignment cannot be accidental. Alignment across distances demands intention. I stood above the space where the vessel once sat, imagining the unseen system that once connected it to the buried conduits, a system with no name, no remaining machinery, no acknowledged purpose. Only evidence and silence. The workshop, like the roundhouses and stations, appears to have inherited its foundation from a structure older than the workshop itself. The vessel was added much later, but not by imperial engineers. Its alloy indicates knowledge inconsistent with 19th century metallurgy. Why install advanced machinery atop older foundations, only to remove it decades later? Why leave no records of its function? Why fill in the conduits instead of studying them? Each question pressed outward, expanding the space of uncertainty. And each pointed to the same conclusion. The machinery did not belong to the rail system. It belonged to whatever system came before. I returned at last to the Vozvijenka depot, the place where my investigation had begun. What once seemed an unremarkable structure now felt like the visible tip of a submerged architecture, just one node in a network of vaults, domes, conduits, and chambers stretching across regions once labeled Tartary. I requested access to the depot's sealed hydraulic cavity, the one noted in the 1964 renovation survey. The seal had cracked further since my first visit. With careful leverage, I pried away a corner of the concrete patch, revealing enough of the cavity to illuminate it fully. The interior was more complex than the borescope had shown. Radial grooves extended outward from the central depression, forming a perfect geometric pattern. The grooves matched, with unsettling precision, the foundation markings beneath the Star Fort ruins in Tobolsk, the platform beneath the Novosibirsk vessel, and the stone corridor beneath Ryazan. When I mapped the angles, I found they aligned, not metaphorically but literally, with the angles connecting the stations in Kazan, Omsk, Tomsk, and Samara. Each site formed a point in a larger radial star. This was not railway geometry. This was something else, a macro architecture, a continental lattice. Modern rail lines happen to follow the same alignments, but they inherited these alignments from older structures. At the center of the radial geometry, the sealed cavity's depression narrows into a vertical shaft, only a few centimeters wide, descending into darkness. Its depth could not be measured, its purpose? Unknown. One last time I examined the 1891 photograph of the depot workers, behind them the arch. In their expressions, no awareness, no fear. But the arch behind them belonged to a system they did not build. The depot's blueprint had denied its existence. Renovations concealed what they could not explain. Records ignored what they could not categorize. I placed the photograph beside my modern image of the sealed cavity. Together they formed a visual echo, a curve repeating across time, resurfacing wherever the soil allowed it. A quiet realization settled over me. The modern railway system may be nothing more than a surface pattern draped over an older, erased infrastructure, one that once connected regions across the land labeled Tartary. I closed my notebook feeling neither triumph nor certainty, only a somber recognition that the past is never as clean as archives wish it to be. And the most important structures are often the ones left buried. The 1891 depot photo enlarged, workers blurred by time, tools resting on packed earth, light falling unevenly across the half-built wall, and behind them the sealed arch, no caption, no identifiers, just a fragment of curvature echoing across continents, across centuries. A reminder that beneath our constructed histories lies another architecture, one we inherited, one we covered, and one we still do not understand.